Hello everyone and welcome to this one-off episode of Unreal Engine 5 tutorial. This was voted for by Patreon members and YouTube members for their support, so thank you so much for voting for this video. In this video, we're going to go through the process of showing you how to create an aiming reticule for your grenade throws. This will show you a line of where the grenade is going to go using our Niagara particle system. So let's take a look at how we can use Niagara to generate sprites on a path. So we're going to start things off by creating our grenade throwing in first person. And I'm not going to worry about doing animation just because I don't have an animation to use. But obviously you can tie this to an animation if you so wish and desire. So what we're going to start off with is we're going to create the grenade itself. So we're going to create a blueprint class and we'll choose an actor and we'll call it grenade. And we're going to go inside this grenade actor and we're going to add a projectile movement to it, and we're also going to add a sphere collision, and this is going to act as its main root. So we drag it to the root here, and we can set up its width and its radius over here to 16. I then want to drag in a sphere for my mesh for the grenade. Obviously you can use any mesh you want, and I'm just going to scale this down so it fits inside of my ball there. Okay, so on the projectile movement, we're going to go over here and set up the initial speed and max speed. And the grenades are going to typically be quite slow. So we're going to go for, let's say, 1200. 1200. And we want it to bounce. Yep. I'm going to turn that on. And gravity, yep, 1. We want that on. Yep, that's all looking pretty good there. Okay. So compile that, and then we're going to set up and create the explosion effect as well. So I'm going to create another blueprint class. This is going to be the explosion. And in our explosion here, we'll add in a particle effect. Now, the one that comes with Unreal is a cascade particle system. So it's like the older version. So be looking out for that one. It's cascade. It's the one with the white underline. So I click on here. I can choose explosion. And there it is. And if you want, you can make it do damage and do other things, but we're not going to worry about that. Here, we'll just leave it as such. So I'm going to go over to a class defaults from explosion. And I'm going to type in here life. And for the lifespan for explosion, we'll just put in 1. Okay, so it's 1 second long. And then it'll get destroyed. So save that and compile that. Close that. Go to a grenade. And on our grenade, we go to class default, set the lifespan for this thing. We're going to do, say, 3 seconds. So after 3 seconds, it'll explode. So on the event graph, we're just going to go and do end. Actually, we'll do destroyed. Destroyed event. And on destroyed event, we're going to spawn actor from class. I'm going to choose our grenade. And we're going to spawn it at the same location as our not grenade, spawn an explosion, sorry. Do that again. Explosion. There we are. And the spawn transform here, you do actor transform. Okay. And then when we've finished here, we'll do no, leave it like that actually. All good. Okay, so now we're going to do the actual launching of this from the player character. So I'm just going to my player character. And I'm also doing my right click button. I'm going to do a right click, the right mouse button. And we'll do it so that when we release the button, it's going to spawn this projectile. So spawn actor from class, choose the grenade, and give it the same location as our player character. Okay, and that will spawn out our projectile. So let's close that and take a look at what this looks like in game so far. So you saw it went through and bounced. And it's getting colliding with my character. So I need to make it so it ignores me. So let's go into grenade here. And we're going to go to begin play. And I'll drag out my sphere. We'll drag out both of these actually. And I'm going to do ignore actor when moving. When you do this on begin play, it basically makes it so it cannot collide with that particular actor. And I'll do it for both of them. And the actor we're going to ignore is going to be the owner. So get owner. And should ignore should be true. And what that means is we have to actually set the ownership of this grenade on the launch of it. So I'll go to my player character and go look at the spawn actor for the grenade. Show the advanced options. And owner I'm going to do is self. Okay, now let's try that out this time round. So they're still hitting me a little bit. So let's make it avoid that completely by going over to our grenade. I think it's the sphere here that's causing issues. So we go down to its collision presets and I'm going to change it to custom. And I'm going to make it ignore pawns or overlap pawns at least. Like that. Okay, there we go. So at the moment it's launching out, but it's not following where the camera's looking. So that's because we are launching the grenade at the actor's current transform, so whichever way they're facing. We also want to go whichever way the camera's facing. So on the actor transform, and rather than using that, I'm going to use the camera. So drag out the camera and do get actor, oh, not actor transform, get world transform. It's a component and plug that into there. So now when you launch it, it should now go where the camera is looking. Okay. So that launches with the camera. But as you can see, it goes through the floor. And that's because I need to go into the grenade and set the sphere collision that we're using here. The main shape. We want to use that for its collision. So go over here to the collision presets and change that to a physics actor. And that should be a little bit better. There you go. And it should blow up. Bang. There you go. So there's a grenade. Okay, so the basics of grenade, and if you want to make it do damage and things like that, you can do. I've got a video all about grenades, so you can do that a little bit more in detail there. But I wanted to quickly go through that so we can actually get started with what we want to do, and that is presenting to the player this grenade line when they are holding down the button. So the way we do aim prediction is in our player character. When we hold down the right mouse button, we want it to start doing a predict projectile path. So if you type in predict projectile path advanced, we need to be using this node to calculate this path we want to use. So there's a few things we want to do on here before we get started, and also we need to update it all the time whilst we're holding down the mouse button. So right mouse button is no good as it is using press and release. So what we're actually going to do is use enhanced input actions to handle this for us. So let's go to my input folder, create a new action for this. Input action, IA grenade. And I don't have to do anything else to that. Just need to go back to my context for IMC default. And I'm going to add in here IA grenade and choose my right mouse button as the option. And that's it. Don't have to do anything else on here. We're going to just do that. And what I'm going to do then, instead of using right mouse button, is use the IA grenade. And the reason why I want to do this is because we can use the triggered, started, and completed to handle all of our work here. So the triggered is basically like as if you're holding down the mouse button, it's triggering the whole entire time you're doing it. Started is obviously when you push the button down, it starts triggering, and completed is when it's finished triggering. So completed is when we actually want to spawn the grenade. So I'm going to drag that to completed there. On started and, on triggered, we want to start doing this predict projectile path. So we're going to go to triggered, plug that into there. And here you can see prediction parameters structure. Dark blue means it's a structure. And with a structure, you can drag it out and you can do make predict projectile path parameters. Click on this. And there are your parameters you can use. Now, there's lots of parameters we can go through here, but we only need a few of them. So first of all is a start location. So the start location for our system is actually going to be a component on our player character. So for now, we're just going to add a scene component. So let's just go add a scene component. grenade source, we'll call it. And I'm just going to position that so it's slightly above, more in line with the camera starting to the side a little bit. Something like that. And I can drag that out and get its world location for the starting point. Now, the launch velocity is obviously, as it sounds, how fast you're launching it and which direction you're launching it. And we're launching the grenade at 1200, because that's what we set the projectile component to. And we're also giving it the direction of our camera. So if we take our camera and we get our forward vector for it, and then from that, I'm going to multiply by a float. So convert to float and type in 1200, because that's how fast we're throwing it. And we're then going to plug that into the launch velocity here. Okay. And here you can set up a few things. So projectile radius we set to 16. So do that 16 there. We'll do trace with collision. We'll turn that on. Max sim time. This is how long it's going to simulate for. So if it's traveling through the air for a longer amount of time, you may need to increase this number. We'll see how it looks for hours in a minute. Trace with channel, whether or not it's going to use a trace channel or if it's chasing with collision. So if it is by default turned on, you're going to be using this channel here to detect when it hits stuff, which is useful for bouncing off the walls of the environment because it's world static and other options available to you here. If you expand open, you've got things like actors to ignore. I'm going to drag that out and do make, and we're going to plug in our self into there, so that way we don't accidentally collide with ourselves and get some weird results there. Sim frequency, so this means it's going to do 20 points per second. So if maximum time is 1, 20 means we're going to see 20 points appear. Override gravity Z, so if you're throwing a grenade that's like got less gravity because we've tweaked this gravity settings in its physics, you can override that here. And you've got the debugs. So I'm going to draw a debug on here for 1 frame and leave that as projectile path there. So hit compile and save that, and then go back to my game. Hold down right mouse button. You can see the projectile path is being predicted like so. Okay. And if I let go of the mouse, it will launch it more accurately. Well, actually, we are using the wrong location. Let me go back into that. So we changed it to be going from the source location here. So let me get the grenade source and attach that to the camera. That'd be better. Yep. And get the grenade sources transform. There we go. Right, let's see if that's better now. There we go, much better. Okay, and you can see, like, if I aim this like to hit this blue block here, it'll hit the blue block there. So you can be quite accurate with this. It works pretty well. Okay, so obviously that's debug, meaning that we would package the game, you would not see it. It's only there for testing purposes. So our task is now to take that debug and make it visual using a Niagara system. So I'm going to go and create a new Niagara system. I'm using 5.2, so Niagara system icon looks a little bit different, but it's essentially the same. I'm going to create an empty system, and we'll go NS for Niagara system and call it Aimer. Open this up. And if you want a crash course in Niagara, please do check out my videos on the Niagara system. I do go over it in a lot more depth, so you can understand a bit more what we're doing here. But I'm going to speed through some of the basic stuff because I want to get to the most important bit of this. So we're going to create an emitter and do an empty one. And I'm going to choose my sprite renderer. I'm going to choose my material that I brought in. So T Aimer sprite map, and on the emitter update we're going to add a burst to this. So spawn burst instantaneous, and I put in however many I want to spawn in. So at the moment you see there's 1. If I put in 20, we can get 20, and it's going to look a bit weird because they're all layered on top of each other, but that's all we need to know for now. So now comes a tricky bit, how to make it so it puts them all in a line exactly where you want them to be. So this makes use of user parameters. So I'm going to go to my user parameters down here. If you don't see it, you can go to Window, you can turn it on, user parameters. And we go to our user parameters choose add, and you're going to add a position array to it. And we can leave it called position array if you want. You can call it whatever you like. And then we go over to particle spawn and go to initialize particle. So initialize particle, we've got the lifetime. We're going to turn it down to like 0.2. Yeah, so it's very short. Don't want it hanging in the air for too long. I'll bring it down there. There we go. And we're going to change the position mode. So position mode, by default, is going to use simulation position. So basically wherever we spawn the system. So we're going to change that. We're going to click on this and change it to direct set. And the position, we're going to click on this and we're going to set it to a new parameter, our position. So we go to position and click a little down arrow over here. And you're going to search for position. And in there, you'll find is select position from array. Click on this. The array sampling mode is not random. We're going to choose one that's direct. The array we want to use, we're going to change that and use our position array here. So type in position, and you'll see the user parameter position array. And now we've got direct array index. So direct array index determines which item in that array. So an array is basically a list. So it's going to give us a list of points. We want that to be dynamic though, based upon which particle gets spawned in. So there is actually a setting we can use for this. If we go direct array index and click on a little down arrow here, we can search for the particle return particle ID attributes. Click on this, and the particle ID attribute, click on there, and you do particle index. Now you're going to get an error, little red warning here, and that's because we need to make sure our properties for this have got ticked on requires persistent IDs, and that'll clear that error out. So what's going to happen is when it spawns in, we're going to give it a position array, and it's going to assign each particle to an element in that array, and it's going to go sequentially through it based upon which particles spawn in. On this aim as well, we're going to click on here, and I'm going to change its loop duration to be 0.2 as well, so it's nice and short, like so. Okay, we're going to close that for now, and we can close that as well. And let's go back to our player character. So on our player character, I'm going to click on the grenade source, and I'm going to add Niagara particle system, and we're going to give it our aimer. And you should hopefully see your position array appear in the user parameters section here. Okay, so you should see that. So what we need to do now is take this result, break it down, and send it over to our Niagara system. So it's a bit weird way of doing it, but it's the only way I found that you could do this, at least in Blueprint. So we take the prediction result here, and we're going to break it open. In there, you're going to get path data. We're going to go through that and do a for each loop. That's going to give us a struct here that we can right click and split, and it goes to the location, the velocity at that location, and the time at that location. So we can go for each one of these. And what I'm going to do here is build up an array of vectors to use. So I'm going to go to my variables. I'm going to add a vector array and change that to vector array. And I'm going to drag that out and add to it in the loop body, add a location. And when it's completed, we're going to take the Niagara system out. So drag out our component here and do set user, actually not user, we'll just do set position array. There we go. And override name is going to be position array. And the array data is our vector array. Okay. Now, there's an inherent problem with this because this is happening on basically a tick event. This array is going to get very large. It's going to do this a lot. So what we need to do is go through it, assign it, and then clear it. So at the start here on the triggered, we're going to take the vector array out and do clear. And that's going to clear the array of any values. So what we should hopefully see is our Niagara system updating all the time with a new position for each of these array, each of these sprite positions. So let's take a look at this in game, and let's turn off the debug of that. Actually, that might help. Go down here, choose none. Yep. Okay, so nothing coming through there. Right, let's work out why that's not coming through. Be on triggered here. We'll do a print string on this. Actually, we'll just do a print string here. Make sure this is getting fired all the time. It should do. Yep, it's getting fired all the time. So that's correct. Now, if I spelled this correctly, position array. Yeah, I believe so. Go into here. Position array. Oh, it's got a space in it. There we go. That helps. And if I now put that in there we go. And you can see the Niagara particle system kicking in there. Okay. Obviously, we don't want it to stay in there though. So we need to turn it off and on. And that's quite simple to do. We're going to go into our input over here. And on started, we're going to turn our aimer on. So we're going to do activate. And on completed, we're going to do deactivate. And I'm going to turn off the particle system. It's auto activate. So that way, don't just see it everywhere we go. Okay, so everything normal right now. If I want to aim my grenades, you can see we've got grenade points here. Let go, and away it goes. So here you can see that's what I mean by the time that I mentioned on the prediction here. So 1 second, that's 1 second of travel time for that grenade going through. And so you can tweak your prediction so it doesn't have as many or goes for longer. So for example, if I change maximum time here to 2, and if I change the sim frequency here to 10, I'll only get 10 per second. So I'll get 20 overall because I'm going for 2 seconds. And you can see they're a bit more spaced out now. And I can aim where they're going. Obviously, it works best in a third-person game. But the logic's the same. Now, as you can see, they are a bit jumpy. And that is literally because the particles are set to end at 0.2 seconds. So they're only on the screen for 0.2 seconds. So if we want it less jumpy, with sacrificing performance, so you do what you want to do with that, depending on what you're trying to do with your game. Just go to the initialized particle and change the lifetime here to a lower number. So 0.05, for example. If I change the loop on the thing as well, the system here to 0.05. Won't get any weird flashiness. And now you see it's a little bit smoother. Yeah. And you can keep going down further on that if you so wish and desire. So there you go. A very simple way of setting up a aiming system. It's not perfect. You can obviouslly tweak those values to get it a bit smoother if you want. And there are no doubt other ways of doing it too. I did experiment with spline meshes and splines as well, but this seemed to be the most straightforward and best looking result. So for now, this is the best way I found of doing it. But if I do find a different way of doing it that I think is better, I'll no doubt make another video too in the future. But as I say, this seems to work just fine. And I kind of like the using of Niagara to solve this problem. It was interesting to look at different ways of passing through parameters to read differently and spawn particles in different places. It was I found very interesting when researching this topic. So thank you so much for everyone who voted for this video. And if you like this video and want to see more content early, please check out my Patreon at patreon.com/Ryan Laley. You can find all my videos early from just $1 a month. As a thank you to all my Patreon subscribers and all my YouTube members for their continued support. Thanks for watching. Make sure you're subscribed, and I'll see you all next time. Bye everyone.